Hello, minasan, mambo des. Today we are gonna start with a dynamic programming problem. So, okay. So first, let's start here. This problem is called buying tickets, and here to state the problem, we have n people needing to buy tickets and standing in a line, numbers sequentially from 1 to n. So each person needs one ticket, but they can buy up to 2 tickets, and that person can. Okay, so the the I person can ask the person before them, the I minus 1 person, to buy the ticket for them. So for a person, we can buy for the next person. Okay, so let's so they are cost for that person buying that ticket by themselves, or that person buying for him and for themselves and for the person before them. So there are two types of individual costs. Okay, so let's draw our example here. So there are people from 1 to n, and let's start with our example. There are 5 people, and the cost for individual buying is 2. Okay. The cost for buying is 2. Okay, wait a second. How do I hide this? Okay, cost is. Let's continue. The cost is 2, 5, 7, 8, and 4 for each person. This for buy 1. This for person 1, 2, 3, 4, 5. And for buy 2 means buying for the person before them. So the first is for 9, 10, and 10. Okay, so let's look at the our question is to find the minimum time to buy all the tickets for everyone here. So okay, let's build up the problem, and say we start with person 1. Then we can, there's only one choice, that so we start with 1. There's only one choice, 1 to buy that ticket by himself, so the total cost is 2. And next is for person 2. There are 2 choices here. Either he buy it for himself, or he which costs 5, or he buy for both which costs only 4. Weird, because buying for both costs less time than buying for one. Okay, so the optimal choice here seems to be choosing to buy 2 here. So the total cost for buying up to 2 is 4. Next one, 3. 3 also have 2 options here. You either buy this for him, buy the 7. So okay, so either buy by 4 or by 5 plus 3. We can buy for himself, so it can be the previous cost plus 7, or if we buy for 2, it can be 9 plus 2. So here, or this one. So the optimal choice is that we buy for 2. So we have the total of 9 plus 2 equal to 11. Next, we keep choosing optimally. Either we buy for 2, which is 10 plus 4, or we buy for 1, which is 11 plus 8. So the choice is obvious here. We 10 10 plus 4 is 14, which is optimal. Next is 14. We either buy for the 5th person, or we buy for both 11 plus 10, or 4 plus 14, so 18. We choose here, which is optimal. Okay, so the way to solve the problem is that we keep building the optimal sum of the person up to the 8th person. Okay, so we have got the algorithm here. Let's state it. Is that the result? Okay, we can go with dp for I equal to minimum of dp I minus 1 plus the cost for I, which is ti, or the dp I minus 2 plus ti nope I. Okay, yeah, we have the formula. So let's solve our problem. Okay, let's solve it. Okay, first let's take the input. Okay, let's start the timer first. As a tradition, when you see Mambo, you just need to start the timer. And so the problem with me is input and the number of people in the array. T also n values and vector t r also n values, and we iterate. Next we iterate the value equal 1. Okay, we have the two arrays here, so let's compute the dp vector. Cost until we call it the cost up to index, call it n. Okay, and the cost for buying two people starting from the first index is let's assign a very big value, so that we do not choose it. Okay, should be big enough. And now let's build our computation array. Actually, we can calculate it instantly. And for the and one less, and the result should be that minus 1. We calculate the minimum. minus 1 plus ti. Oh, if we can greater or equal than 2, then cos of the index I equal minimum of that or I minus 2 plus I. Nope. This is enough. No. Okay. Should be enough for our case here. Initiated. Okay, let's offset it by 1. Yeah, okay, yes. Go to I. Okay. Actually, this should be the correct answer. But I wonder if we can make it cleaner. Plus okay. Looks cleaner. Okay. Actually, let's make it better. Let's go to the right of n plus 1 values. So the cost up to the first index equal to t0. Okay, is that +1? It can be the minimum of that, and case one we choose. Okay, so we choose. Okay. Okay, this code look clean. We calculate the cost up to the n index. The first person will always be the cost of the first cost will be the single person cost, and for the consequent cost you can choose the previous person plus this person cost previous optimal, or you choose the two previous optimal plus the this and previous person cost or AI cost. Okay, let's submit. Oops, we are wrong somewhere. Oh, okay, I'm wrong here, sorry. T1. Okay. And we are done with our first problem of today. Okay, let's stop our timer. 15 minutes. Okay, let's go to the next problem. So Marisa has n bookshelves. The ith cell contains AI books. So you want to take out K books to read. So you take at most one book from each bookshelf. How many ways you can choose K books? Okay, so first we try so for our example here, let's say she had 3 bookshelves and she want to select 2 books, and we have bookshelf up side 1, 2 and 1. So she have 2 ways. So we can choose one from these. So let's go with our option. We need to select 2 books. So the first obvious option is 1, 2, 3, 4, 5. There should be 5 ways to select books. Okay, so let's come up with a way to show this. So we need to meet our quota. So we select one book here, 2 books there. Okay, so let's get with a more complicated example. We want 3, 4. For example, this is 3, 4, 2, 1, 2, 2, 2. So we can choose one of the 3 options here. stack and Excel we can only take one. So it's so if let's set the quota for us for so we need 4 here, then we can choose any of these, first, second. So our naive option is that we count the number of ways for each choice here. It means we can count. There can be 2 to the n choices if we select root for all possibilities. But let's think more thoroughly. Here we start at 3. We can select it or we do not. We can go to 4. We can go to 2. But we cannot never go to 1 because we won't have any cost left. So if we look backwards, we need, when we are 2 here, let's find number of ways so that we can add to it includes the 2 here. Is that this one need to be a 3, sum of 3. How many ways to have a summation of 3 in the thing in BIP? For this, and so the sum of 2. Here sum of 3. to select three options here. Difficult. Okay, so let's visualize the way we choose. Start here, we can go to here, and we have three cards left. Okay, we need to consume all the cards. Then we can go here and two cards, here and one, here and 0. Okay, so if we go forward, next way then we go here and have cards up 3. Then we need to calculate the cards 3 at the index 2. We haven't calculated it yet. So there are many ways. Okay, so let's start with here. And we need to, we can either consume, or we can either take, or we skip and we go next. And if we take here, okay, so let's visualize our first example. We have cos of 3, cos of 4. So at the first index we have the cos of 0. We haven't taken now any book, so we have two options here. So there is one way to not take out any book, and okay, so starting from 1, 0, 1, 2, 3, 4, 5, and the energy left is 4, 3, 2, 1, 0. The books that need to be chosen. So if we choose 0 book at the, we want to keep 0 book as the first index, and there's one way to three books. There's three ways. Two books, zero way, zero, zero. And next is if we want to keep four books at second index is one way. Okay, so this is one, and one. Here two books. We either take the book at the left, which means three ways, or we take the book at our current index. So far, so totally there are three ways. Plus four ways equal to 7. Then to have two books, there is just one way. Next is at the third index, we can 3 plus 4 plus 2. To have three books, we can select from three ways here, two ways there. So that 2 plus 3 plus 4 equal says 9 ways, and 2 since there are 7 ways to keep 3 books. No, I'm getting it wrong. So there's 7 ways here. Zero, zero, and zero. And here there is one way, zero, zero. And next is up to this. The 2 we had 7. There 3 7 plus 2 9 ways to have 3 books, and at 2 we have since there are 7 ways to have 1 book, 2 book up to the first index. We can just take 1 book. 3 multiplied by 7. Nope. 3 multiplied by 4. Twelve ways. 3 multiplied by 2, 6. So 12 plus 8 plus 6. No, this one doesn't work. So total 26. Now 7 ways to take 1 and 2 ways. So 7 2 ways to take this one. 40. One way to keep 4 and this way to choose fuck up. So we need to find a way here. There's just one way to have one cause. One way to have the cause. 3 cos and then summing up with 3 4 2 2 no. Doesn't work that way. Okay, so we need how do we calculate this? So here is the cos lamp. There is the index. So there doesn't seem to be an overlapping problem here. Nope, there must be, but we are doing something wrong here. Here's a number of ways to keep cost up 3, 7, 9. Okay. What should I do? Cannot. Okay, so let's let's make a bigger table. Three plus 4 plus 2. And here is a nope. 3 multiply by 4. Okay, so we can calculate the product of all of these. minus the previous. Three multiplied by 1, 4 multiplied by 1, 1 multiplied by 1. Okay, so we have exhausted all the combination here. Then we can combine the previous combination with this. Okay, we from here. Can I have all the ones? I need to go out. Okay, so I'm back. And we need to okay, so how we can derive the previous values here. And the next is we can derive by finding how many combinations. Already here, and next is a combination for one, and the things that are already here. Okay, so it's like this. Let me repopulate it. 3, 4, 2, 1, 2, 2. So 1, 2, 3, 4. Let's see it in one here. Three ways. Next is three way plus 4 equal to 7. Is 9, 10, 12, 14, and next is 0 here. One here. So we can keep with the previous combination and multiply by current. Actually not. Six. Yeah, it's 12. Okay. 12 multiplied by 3. So here everything can fit in the blank. Here. Let's. We need 1 and we can combine with the number of combination here. So it's 7 multiplied by 2 equal 14 plus 12 is 26. Okay, we are going in the right way. Next is 26 plus There are 10 ways here. No, that one way here. Plus 9 previous way equal 35. Let's validate it manually. 3, 3, 4, 3, 2, 4, 2, 2, 1, 4, 1, and 3, 1. Okay, we have come with a solution here. It took me so long, but I finally understand the logic here. So after we have so let's say the bottom here is how many books that we have chosen, and here are the cells. So we can select the books within, can build up the list gradually. So this one is equal to the previous value plus okay, so we can get the previous combination and plus the combination that takes less than one value, and plus a new value here, plus multiply by the ways to choose a new stack of book here. So it becomes 3, 7, 9, 10. Okay, so the value here is this value plus the multiply of these two, and this one is also, so here is plus a multiplier previous value plus a multiplier of these two. Okay, we have finally tabulated. So the DP of index and cost equal to the DP of previous index cost plus the DP of previous index and previous cost multiply by dp up multiply by the current cost the value of the cell I. Okay, we have derived a very fucked up formula. Okay, so let's tabulate. Okay, first is that we take the integer n and the constraint n and k. There are n book sales and we need to pick k books. So we create an array of ways to choose by cost at index. It contains take a k plus 1 cost and books and plus 1 books assign with value 0. So we populate the first line. There one way to take 0 book. Zero cost index I equal to 1 and okay, next is ways to take it to take cost at index. Okay, let's give it n books. Index 0 cost 1 at index 0 equal to okay, let input 0, right? invoice to take book but equal A0, and now we populate the table. Equal to one. Cost equal 1 less equal than less or equal than k cost plus plus for in index equal to 1 second less than n index plus plus. So why take it by cost index cost index equal to -1 plus multiply by the current amount of book, number of books in this book shelf. I index. Okay, and finally we return the way to take because at index. Okay, at index n -1. And this should be the right answer. Cost -1. Okay, it seems right, but now we need to we also need to modulo to preventing overflow. Okay, and this should be the correct answer. shorten the variable. This look too long. Okay, we don't need the percentage mod. This here should be enough. Okay. It's, the first dimension is the cost need to consume. Number of books chosen. Dimension equal to up to index. Otherwise, choose. This one should be right. Let's try submitting it. Oops. Something not right here. Okay, so we need to use a long. Let's convert everything to long. Because we are multiplying two costly value here. Okay, let's try it again. Oops. Huh. Oops. Should be less than 8. Okay. Try again. Okay, accepted. Yeah. Yes, we have got the answer here. This one is tricky. I hate it. But okay. At least we need to learn combination better. Yeah. So every day we need to visualize. Okay, so the key to dynamic programming problems is that you should visualize it well, and then and everything will be correct. It will calculate itself. You just need to visualize, find the relation, and yeah, you get the relation and you translate it into code. And if your code runs, it will calculate itself, and you get accepted. Yeah. Okay, that's enough DP for today. Thank you for watching, and I might stream tomorrow or not. No, but if you want to watch me struggling with competitive programming problems, then stay tuned. Bye bye. I will upload the answer.